Hi guys, this is Ashish. I did my masters in designing from IISc Bangalore. I secured an All India rank of 10 in CEED 2014 and got admission for industrial design at IIT Bombay and IISc Bangalore. I have a work experience of 4 years as an industrial designer, and I've also worked as a professor of design. I will be updating some relevant content for design entrance examination and some strategies along the way to help you secure a good rank and be thoroughly updated with all the current happenings and basic knowledge that is required for these examinations. So stay tuned, guys. To the video. So today I'll be solving the UC 2019 question paper. So I'll be solving the NAT part of it. So in this paper, a lot of mathematics was involved, but you can be rest assured like mathematics is the basic 8, 9, 10th level mathematics. Just what is important here is how you manipulate shapes. How you understand shapes, how you can simplify the mathematics, because it will not be a lot of physics, sort of mathematics, but a lot of spatial ability and observation skill will be checked here. So nothing to worry about. The NAT part was a little tough this year, I agree. So, but it was pretty simple if you just had little observation skills. Yeah. So I'll just go ahead with the video. So the specific paper instructions, you also read that well before the examination, before starting the paper. So the section A carries 60 marks, section B 60 marks, 20 questions, and 45 questions. So this year they have changed the pattern a bit. Now they have a sketching part as well to test your sketching ability. So that also you have to take care. The marking will change here. Yeah, so guys, I'll just go ahead with the section A part of it, the NAT part. Yeah, okay, so question one. So you have to match the identical pairs and identify the total number of matched pair in this image. Yeah, so here this one is matched with this one. You can see this thing. Yeah, if you only match the above part, that will be fair enough. You'll be able to get through. Yeah, this pair, this little shape is matched right here. Yeah, so this one is matched. And if we see here, this kind of a flowery pattern uh, matches around here, this one. Yeah, so a lot of pairs have been matched. So three of them here in the first question. So three patterns are being matched. Yeah. So rest are just a little bit of change in everyone. This one is almost not a mirror image, it's just the same image. This one doesn't match. Yeah, so three pairs are matched here. Okay, all right. The second question, so x1 is a figure formed by manipulating this image, and certain observation operations are being carried on this image. You have to count the number of surfaces on if this image is taken and same operations have been performed. So if you see this diamond figure, yeah, it has been stretched down, just like if I take the side view, it has been stretched here and then stretched like this. If I take the axis here, yeah, so I've taken a 2D view of this here. Okay, so this has been stretched here and then came down. So that's why what you're seeing is uh, five faces on the above part. Yeah, sorry, seven, one, two, three, four, five on the down part, and six on the above part. Yeah, one, one, two, three, four, five here, and one on top. Yeah, six faces. So if I take this figure, so how that manipulates is like I can take this figure and same this bridge is there, then this diamond shape is there. Yeah. So if I try to stretch it, it will form a cylinder, this thing, and this will get stretched out, and I'll see a triangle here, and this part will also get stretched for down. Okay, so if I count the number of faces here, so the number of faces would be uh, 1, 2, 3, 4, 5, 6, 7, 8, 8 faces. Then inside also I'll have some faces. 1, 2, 3, 4, 5, 5. Yeah. Then on top one also I count. Yeah. So I have 14 number of faces here in this one. Now I stretch it, this way. This one plane I take. So, I stretch it like this and then stretch it like this. Yeah. So if I stretch it like this, so this section, this part would be gone. This little part that will be gone in this. So if I stretch it around here, so it will form the same thing. Yeah. But this part will be gone because I'm stretching it here. So the number of faces in that part, so this part would not be there. So we count the number of faces: 1, 2, 3, 4, 5, 6, 7, and this one 8. 8 faces will be there on this. Yeah. So 14, if we count here in the above, it will be 13. But one here, there will be one hole here. So you have to count that face also. That's why this 14 is coming and down. Only the outside part, this hole you can avoid. Only 8 faces will be coming. So 14 plus 8, that turns out to be 22. Okay, so you can leave your comments in the section below if you're not able to understand. I'll send you a 3D figure of this one. Yeah. Okay, so guys, coming to this question. So now here, 15 people are there who have come to a family reunion, and they each exchange two gifts and they then hug each other. Yeah. So one person is giving two gifts. Yeah. So 2 into 15. These are the number of gifts. Okay. So one person has got these many gifts. Okay. So 15 people would have got, 450. Yeah. Now, this person will not give a gift to himself. So if we have to subtract that number. So that turns out to be 420. Yeah, so these many gifts would have been exchanged. Yeah, two other number of gifts one guy buys. Okay, he has to give it to 15 people. Yeah, so one guy gets 30 gifts. 15 people would have got 30 into 15. Yeah, but he'll not give a gift to himself. So 30 have been subtracted from it. From each person, two gifts have been subtracted. So 420 is the number of gifts exchanged. So now the second part, number of hugs. Yeah. So, how to calculate unique number of outcomes in probability is to, first see how many events are happening and what is the occurrence. Okay, so that will be two occurrences are there, number of events are 15. So the formula for that is NC2, yeah, or, so 15 C and two number of outcomes are happening. So that turns out to 15 into 14 divided by 2, that is 7105. So the answer would be number of hugs 420 minus 105, that is 315, or 105 minus 420, that is minus 315. Okay, so for this, like, I'll give you an example, like, say, A, B, C, D are there, and one is hugging each other, and you have to calculate how many hugs have taken place. Yeah, so either one is the option like 4C2 in unique outcomes. That is 4 into 3 divided by 2. That is uh, 4, 2, 6 outcomes are there. Yeah. So here also let's see. A hugs B, A hugs C, A hugs D. Then B hugs A, B hugs C, B hugs D. Now C hugs A, C hugs B, C hugs D. Now D hugs A, D hugs B, D hugs C. Yeah, these many outcomes are there. How A, B, C, D are hugging each other. But if you see A, B is similar as B, A, you can cut this out. A, C is same as C, A. Yeah, A, D is same as D, A. Yeah, B, C is same as C, B. Yeah, B, D is same as D, B. Yeah, and here C, D, D, C. So here also you can count 1, 2, 3, 4, 5, 6, 6 number of outcomes. So either you can do this combination or you can just readily get the answer from here. Yeah, so answer was 315 for this. Yeah. So I'll just rub this part to make way for the next. Okay. So any number of unique outcomes you have to calculate, you can calculate by this NC2. Okay. If three number of outcomes were happening, so you can count 15C3. Yeah. So this is the easy way out. Okay, so in this fourth question, what is happening is, this tetrahedron is given. Tetrahedron is basically this image that is given to you here, which has one, two, three, four sides. Yeah. So, puzzle is given. You have to calculate like how many, tetrahedrons would have been here for making this. So if I see here, one tetrahedron at top, this yellow one. Yeah. Now, one tetrahedron, this green one. Yeah, like the second row. Yeah, and one would be here. Okay, now if I see the other face, this face that is not visible to me, here this will be completing a shape like this, and here I'll be having one more uh, of this tetrahedron. Yeah, here also this is happening. Okay, so one tetrahedron would be just fixed right here, here, this one, and here one would be here. Okay. Similarly, on the other side, this, if I turn this from this side, I see, so this would be happening, same one tetrahedron is here, one is here, and one is here. Yeah, and this is how the shape is being completed for the second row. Yeah, so if I count, so one is here, one, two, three, four. Now, in this way, this is already counted. So one, two, three, four, five, six. Six are there. And then on the other face from here, the yellow side, only one I'll be counting because this one I've already counted. This one has been already counted. Yeah. So, that's how I can calculate for everything. So here I'll be having only one tetrahedron. Here I'll be having one, two, three. On this side, I'll be counting one, two, okay, 3 plus 2, and on from this side I'll be calculating only 1. Okay, 3 plus 2, that is 6. From here I'll have the same thing. 1 2 3 4 5. 5 are there in this phase. Now in the other phase, this is already counted. If I turn this, so 1 2 3 4 I'll count, plus if from this side I see this is counted, so 1 2 3, this I've already counted. Yeah. So on this phase, let's see, 1, 2, 3, 4, 5, 6, 7. Yeah. 7 are there. Plus, on the other side, if I see, there are also 1, 2, 3, 4, 5, 6. Okay. Now on this side, there will be 1, 2, 3, 4, 5, only 5. This one and this I've already counted. Yeah. So now, so this is 1 plus 6 plus 3 plus 5. Yeah. Sorry, this one, 6 plus, oh, I have to calculate that. 5 plus 3, 9, that is 12. So this turns out to be 18. So these many surfaces are there. So 1 plus 6 plus 12 plus 18. Now there is also one face, the below part. नीचे से भी देखेंगे. So here I'll be having number of unique faces as 1, 2, 3, 4, 5, 6, 7. Able to get it? These ones. This one, this one, this, this one, yeah, this one, and this one. Yeah, because these are already counted. These are already counted. Yeah. So this one, this is 37 plus 7. So that turns out to be 44 is the answer for this question. Yeah. So moving on to the next question. Yeah. So the fifth one. So here, uh, some of these blocks are given. You have to calculate the multiplication. So the green one is actually equal to 0. So 0 plus 0 plus 0. This is the plus sign in between. The red one is 3 to the power of x, and the blue one is 3 to the power x into 2. Now what does this x mean? X means the position that this block has in this combination. Yeah. So if I see 3, so that is 0 plus 3 to the power x, radius 3 to the power x, so 3 to the power 1. It is first position. So this position is 2, this is 1, this is 0. Yeah, plus 0, so that is 3. If I see 10, how this coming is 3 to the power x, so 3 to the power 2 plus 0 plus 3 to the power 0 because its position. So this is x position. So x is 2 here, 1 here, 0 here. So that is 9 plus 1, 10. Similarly here, so this would be 3 to the power 2 into 2 plus 3 to the power 1 plus 0. That is 9 into 2, 18 plus 3, 21. Okay, so similarly here, this one would be 3 to the power 2 into 2 plus 3 to the power 1 into 2 plus 0. So that is 18 plus 6, that is 24. So here if I calculate, this one would be 3 to the power x, 3 to the power 2 plus 0, and this will be 0 plus 0 plus 3 to the power 0 into 2. So that is 9, this is 9, and this one would be 2. So 9 into 2 equal to 18 would be the answer. Yeah. Okay, the sixth question, a cube has 6 faces numbered 1 to 6. A boy tosses up and he notes down. So you can read the question. You have to calculate the number of unique multiplications. So you can make an array for this 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5, 6. And you can see, how many unique multiplications you'll get. So 1 into 1 you'll get, 1 unique. 1 into 2 you'll get, but 1 into 2 also you'll get here. 2 into 2 you'll be getting here. So you can avoid this. So similarly here, 4, because 4 into 3 is there, okay, but 3 into 4 is there, so I'm not marking that. 5 into 1 is there, this is there, this is there. 5 into 5 is a unique one. Then 6 into 1. So I'm not marking this 6 into, this one I'm not marking. Yeah. So here you get an array of this multiplication. But even in this multiplication, you're also getting, repeated kind of numbers. Yeah. So, the number of repeated numbers here would be, 1 into 1 is there, that is unique. 1 into 2 is there, that is unique. 2 into 2, 4 is unique. Yeah. 3 into 1 is unique. But 3 into 2, and so this one is not unique. Yeah. So 2 into 1, 1 into 2, that is, not unique. Okay, so here you can find out, like, so I'll just quickly mark this. You can calculate that, this one is not unique, this one is not unique. 4 into 1 is not unique because you are getting 2 into 2, 4. Now 4 into 1 is also 4. So this can be avoided. Yeah, 2 into 1 can be avoided. Yeah, so according to that, the number of unique results I'm getting will be 18. Okay, so you can make an array and then you can make, but also to make sure, because 4 into 1 I'm getting, 2 into 2, 4 I'm getting, so you have to cancel out that. Sorry, this one will be there, this one will be there, 2 into 2. Yeah, so 1, 2, 3, 4 of them would not be there in this multiplication, or 18 would be there. Yeah. Okay, the seventh question, two transparent pieces are given. So if I superimpose this, so that will make a complete sort of a figure where I have all these matching. Yeah, if you try to pick this and transfer it here, so it will make a whole figure like this. Yeah, this one would not be there. So yeah, from here, and this one will be there. So you can calculate the number of triangles. I'll not get in there. So you can start from the outside and then come inside, and here. So you can count outside ones. First 1, 2, 3, 4. Then inside, these ones will be there. This one will be there. So total number of triangles that you get here would be, if I calculate that. So you guys can calculate this one. It's pretty simple, straightforward. Yeah. So that is that. Eighth. So one piece moves 2 units and one piece moves 1 unit. And to calculate, where do they align up? Yeah. So this one will, travel two places at once. So this will come here, and this will be shifted here only B, and this will go somewhere here. Okay, and then this will move 2 units. It will come here. Okay, so that's how you can, just manipulate. There is no easy way I could find out, but just manipulating the, you know shape, and then trying to find out where do they align. Yeah, so here the fourth step that comes, this will come here. Yeah, so this one then comes here, fifth step, this one here, and this one goes over there. Then it comes back. Yeah, it bounces back, so it comes back here, and this one is here, and this one is here. Okay, then this comes back, so you can calculate that. So 7 number of steps would be required. This is how I calculated. Yeah, you can do that. Yeah, so the ninth question. So the image is formed by intersection of 2 points. Yeah, so how this image would be formed is, this sort of an image is will be formed, something like this. you know this portion, the front portion, then there'll be a triangle sort of a thing here, and one more surface below, and this portion, this one will be coming like this, and this one would be at the back. Yeah, if you're able to understand this image, so this front is this, and the back, this one is here, this triangle, this trapezium, and then the back rectangle. So here I have 1 2 3 4 5 5 plus 4, the side one, 1 2 3 4 5 plus 4, that is 9 faces I get. Okay, 10th one, you can solve it pretty easily. You can see this square here, this middle square, yeah, and you can count the number of faces, some number of blocks from that. So 3 blocks are being formed. 1 2 3. So 3 into downwards also 3 are there, into 3 into 3, that makes it 9 to 3, 27. Yeah, then outside plus, this plus, yeah, this plus. So number of cubes are 1 2 3 4 5. 5 are there. The number of pluses that you have in the periphery are 6 into 6 30. So 27 plus 30, that makes it 57. That is the answer. Okay, 11 one, one hole is drilled, a cylindrical hole. So you have to find out how many faces will it have. So this will make a, from you know this one, it will make a cavity that goes like a cylinder from here. But in this one, it will not make a cavity per se. What, if I just take this cylinder, and this uh, cavity that is there, so it will just make a small dent here, and it will not be going throughout the surface. you know like it will be something like this. I have this hole. Yeah, so it will be just around the edge. It will not be making a new surface per se. Yeah, so it will be a direct part of this cylinder itself. So number of you know surfaces here would be just, you can count this one. Now this one extra surface is being made. Yeah, but now this will not count as another surface. It will be part of this, this hole itself. So the answer would be 10 faces that it has. Yeah, it will not create a surface here. It'll just be going along, and it won't be all throughout. So here it is, this part is all throughout the hole, but here it is just a part of it, just this part, which will be, not creating much of a trouble on this edge. Okay, the 12th one, pretty simple. Like, so each unit, so this one is 50 under root 6. So each unit, how much that will be? 30 under root 6. So if I take, make a line here, so this length would be 15 under root 6. This one is 90 degree, so this one will be 45. This one is 45, 45. It is dividing exactly into half. 45, this will be 45. Yeah. So this one is 15 under root 6. So how much will this be? This will be 15 under root 6 into cos 45 degree. Yeah, so that is 15 root 6 root 2. Yeah. Now this has been turned to 60 degree. Now this is 90. Now has been turned to 60. So it will elongate a bit. Yeah. So this is 60. So here this will divide into 30 and 30. Yeah. So this is now 30 degree. Okay. So if this is 30 degree, okay, this one, so the projection that this line is making when it is 30 degree, the projection that it is making is 15, so this one 15 under root 6 under root 2, yeah, yeah, into cos of 30 degree. Yeah, so that is 15 root 6 into root 2 into root 3 by 2. So we can calculate 15 into, so this will be under root 18, under root 18, so 2 0 12, 12 36, sorry, 36. So 4 4, so 4 would be that. So okay, so you can calculate that. Okay, so that will be 45 under root 18 divided by 2. That will be, sorry, 2 to 12, 36, 36. 36 under root is 6, sorry, 15 into 6 by 2, that is 45. Yeah, so 45. Now there are 10 sections like this: 1 2 3 4 5 6 7 8 9 10. 10 are there, so 45 into 2 would be the answer. 450 would be the answer. Yeah. So in 13 question, there was a lot of things happening. So some digits are given, some symbols. You have to calculate what will be the addition. So how I did it was from 0 to 9 digits are given. So from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, symbols are given. 1 plus 4 equals 5. So this is 1. This is 4. This is 5. So 1, 4 and 5 are already taken. Yeah. Now I'll assign some digit for this. Say, so this one is 4. Yeah. So 4 plus A equal to B. Yeah. And this also I don't know. There are two digits. So CD minus E equal to, now this is 1, this is 4, equal to 14. This one is 14, 1 and 4. And here I'll say this is F. This is 1, F plus G H equal to something. So from here I can see, this is a 2-digit number. So subtraction, if I take, C as 1, say 19 minus something equal to 14, but 1 is already taken, 1 is already here. So it will be a 2-digit number or a 3-digit number. But if it is 30, I have to have a 2-digit number, to probably arrive at 14. So it will be something by 2 only. So C would definitely be 2. So 2 I cross out. And I see, if I put 1 here, so that will make 21 minus, is something equal to 14. So that is 7 comes here. Okay. So what I did was I put 0 here minus, so 6 will be 14. So D is 0, E is 6. Yeah, so 0 and 6 are also taken. So sorry, this one is sort of 1. 0 is crossed out. Yeah, and 6 is crossed out. Now I see here 4 plus A equal to B. Yeah, so some single digit number is forming. Yeah, so if I see here, so one single digit would be here, because if I take 7 as B, 4 plus 7 will be 11, so this doesn't work out. So this will definitely be 3 and this one will definitely be 7 in that case. Yeah, so 3 and 7 are also taken now. What remains are 8 and 9. Now if we see, this digit, this, F is same as A, this one, yeah. This was how much? 3. So guys here, this digit, this one, uh, this is equal to this one, that is 6. I know that. Now G can be either 9 or either can be 8. Yeah. So 313 plus, so this is 6, either 9 or 8. If I take it as 8, so I get 399. Or if I take it as 9, I get 9, uh, 409. So here, two digits are appearing twice. So 399 would be the option because 9 and 9 are appearing twice. This is how you can solve this. A little logic. Yeah, so guys, in this question, what was happening was, if I just take this triangle, so that exactly fits here, this one. Yeah, so you can take by that, if this much space is remaining here, and this much is being taken, so this same is being left out here and same this is here. So just a basic trick of image manipulation. So I can count how many of these squares are there. So 1, 2, 3, 4, 5, 6 of them are there. Now square is of length 4. So this one would be 4, 4, 4 and 4. Total length is 16. Yeah, so I can calculate this area of this box, that is 4 into 4, that is 16. Number of squares that are there that we counted were 6. So that is 90. 96 is the answer, guys. Okay, so in the 15th question, what was happening was, uh, you know, under root 3 is the radius of this circle. Yeah, so you can just take one center and take under root 3 as the radius. Now, if I take this length, yeah, so this one is 60 degree because this is an equilateral triangle. So how much will be this? So this will exactly cut it into half. If a circle is inscribed inside an equilateral triangle, so from center, this edge will exactly cut this from to this vertex. This angle would be exactly cut into half. So this is 30 degree. This one. Yeah. So I can take sine of this. Yeah. Sine 30 degree will be equal to upon a. So 1 by 2, a would be 2 root 3. So this length is 2 root 3, this one. From here to here, this is 2 root 3. Yeah. So, similarly, this one is 2 root 3. So, what you have to calculate. So, I have to calculate, this distance. Yeah. So, this radius, how much is this radius? Radius is root 3. So, how much would be the remaining part? 2 root 3 minus root 3. That is under root 3. Yeah. So, this length is under root 3. Yeah. So, if I see, this is forming an equilateral triangle. This one will be also 60 degree. Yeah, this is root 3. So to calculate this, I can take again sine. So sine 60 degree is equal to root 3 by this length. So root 3 by 2 equal to root 3 by b. So that makes it b equal to 2. So this length is 2. This is also 2. So you can calculate, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 are there. What you have to calculate is total length of the star. Okay, so I have this length. So similarly, I have 12 other sides. So 2 into 12, so 24 would be the answer. Yeah, simple. All right. So here, you have to, four-digit number, you have to calculate which one is odd from these. So I could see, this 9 here in this one. So 9 is, this is joined, but all the other digits, if you see, 6 has a little gap. If you see here, this small gap is there. In 9, there is also a gap, something like this. A gap is there in the font. Yeah, 6 you can see, and the 9 also you can see. But in this, the 9 is joined, so 1990, because in all the others 0 is common, the the counter here. So circle in the between is called the counter. Counter is similar, and 1 is also similar, the serif is similar. So only the 9 one was a little bit odd. So 1990 would be the answer. Yeah. Okay. So guys, in this one, the 17th one, you have to calculate the number of faces. So if you see, this heart would be only one face. You can start from one side, so you can pick up this one side, and 1, 2, 3, 4, 5, 6, 7, 8 up till here, then 9. Yeah. Then you can just flip the image, continue from here. Yeah, then count, then this will be 1. Okay, so you can count the side ones, then you can count this face, 1, 2, 3, 4, and then the inside 5. So the answer for this would be 23. Yeah, so we can calculate. This is pretty easy, I'll not get into that. Okay, so in the 18th one, you have to see which is not following a symmetry. So what I could find was, so this one and this one, because for that to be symmetrical, this triangle had to be probably like this, in the same orientation. Yeah, so it is pointing down, so it should also be have been pointing down. It is pointing upwards. Okay, so this is a little bit odd. So this is the first one I could see. Yeah, so uh, this one, bigger one. Yeah, this slant is just too much. Yeah, this has a broader thing. Yeah, so this is one. Also, this one. See if you can see this one and this, not symmetrical at all. So this is the third one. Even yeah, you can see in this one, the downward, this one. This is not at all similar. This is the fourth one. Yeah, this one also. This is not actually symmetrical to this. This is the fifth one. Yeah, this one also, not symmetrical. This and this. So that is the sixth one. Okay. This also, this one. This also is not at all symmetrical. You can see this and see this, not symmetrical at all. Yeah. So even this whole figure, from here, you can see uh, this one is also not at all symmetrical. Yeah. This one you can see, you one part is missing. And this one is also not symmetrical, the inside one, this one, this one. So 9 were the total number of, pieces that were not getting symmetrical. Okay. Symmetry means, similarly, like a mirror image. Mirror image is not forming. Okay, so guys, 19th one, pretty simple if you try to decode this image. So if you see, you can form a square right around here. Yeah. So the inside diameter is given 14 root 2. This diameter. Yeah. So either you can do this, this is forming a right angle triangle. This is 14 under root 2. This one would be 45 degree. Yeah. So I can calculate this one. How much will that be? Or you can just use the Pythagoras theorem. Yeah. So 14 under root 2 whole square is equal to this. If I take a, this as b, is equal to a square plus b square. But a equal to b in this image. Yeah. So you can calculate readily 14 into 2 is equal to uh, twice of a square. Yeah, so we can calculate that. So A would be 14. So this side is 14, this side is also 14. And if I try to, just to make this more, one more division, so I get these many circle, the squares. Yeah. So if I calculate this area, yeah, the semicircle, and I subtract the area of this square, then I'll get the area of the remaining part, which is this one. Yeah, that's pretty simple. So I'll calculate the area of this, this semicircle. That will be pi half into pi r square. So half into 22 by 7. Now radius would be 7 because this one whole side is 14. So radius will be 7 into 7. That makes it 11. Now to be 11. Now if I see, if I calculate the whole area of this whole circle, that is 14 into 14 minus if I take, this, and I take the other half as well. So that will be 2 into pi by 2 into 7 square. Yeah, so that comes out to be 196 minus, you can calculate this, so 22 by 7 you can take, so 22 into 7, so this is 154, that comes out to be 42. Yeah, so 42 is the area of this thing, one section. So for this and this whole part, so if I multiply by 2, so that is 84. So the area for this part comes out. Yeah. So if I subtract from 196, I subtract 84. So that comes out to be 112. So that is the answer. Yeah, pretty easy. Okay, last question. So you have to calculate the amount of milk produced by the dairy per day. So you can just, you know, so this was important, this observation, if I can see the place where the milk is being taken from, but this will not be calculated. It doesn't give milk. It gives milk, it gives milk, gives milk, gives milk, doesn't give milk. Okay, so the white one would be 6, and the brown one would be 4, and the yellow one would be 6. And you can just see how much liter they give. That is into 12, into 7, into 10. That comes out to be 160 liters. That's the answer. Yeah, so this basic observation was important. Okay, so this was the NAT part, guys. Okay. Thank you guys for watching the video. Do like, share, and subscribe. And follow us on Instagram and Facebook for getting regular updates on design entrance examination, especially UCEED, NID, and the CEED entrance examinations. Thank you.